Hello, this is May. This tutorial is focused on static forces. First, we need to know what force is. Force is any influence that tend to change the state of the body. And now, we will continue with the static force system. Frictional force is a force that always acts in the opposite direction to the applied force. Consider this man pushing a car. That arrow pointing on the right is the direction of motion, and that arrow pointing in the left below is the force of friction, or the frictional force. And now let's move on with the parallel forces. Parallel forces are forces that are of the same angle to one another. In this example, the parallel forces here are the 400 kN download at the leftmost end, 800 kN downward at 9 meter from the left end, 900 kN at upward at 3 meter from the left, and 300 kN upward at 11 meter from the left. The concurrent forces. These are the forces that meet in one common point. Here in this illustration, the three arrows that points in the middle is the concurrent forces. The non-concurrent forces are those forces that do not meet in one common point. Let's go for the application of static forces. The variables we need to consider are the following. We have R for the resultant. The alpha, beta, and P are for the direction of R relative to X, Y, and Z axis. Here are some basic formula in solving resultant force of coplanar forces. The illustration here is an example of coplanar concurrent force problem. In the illustration, we have three forces in the same plane. The F1, F2, and Fb, all pointing in the center of the plane. To get the resultant force, first get the summation of forces in the x-axis, then the summation of forces in the y-axis. Now, apply the Pythagorean theorem. Resultant will be equal to the square root of the squared of summation of forces in x, plus squared of the summation of forces in y. To get the direction of the resultant force, divide the summation of forces in y from the summation of forces in x. Coplanar parallel forces. Here is an illustration for coplanar parallel forces. To get the resultant force, just sum up all the forces lying on the plane. And to get the direction of resultant force, just sum up the m, where m is the magnitude multiplied by the distance from other forces. Non-coplanar forces. A typical non-coplanar system of forces is shown here. To get the resultant for non-coplanar forces, first sum up each forces from x-axis, y-axis, and z-axis. Then use the Pythagorean theorem to get the resultant force. To get the direction for the resultant force, in the direction relative to x-axis, the formula is cosine alpha is equal to summation of forces at x-plane divided by resultant force. For the direction relative to y-axis, the formula is cosine beta is equal to summation of forces at y-plane divided by resultant force. For the direction relative to z-axis, the formula is cosine alpha is equal to summation of forces at z-plane divided by resultant force. The equilibrium of force system. General condition of static equilibrium. The summation of forces at x must be equal to 0 as well as y and z. The summation of m must be equal to 0 also. Fr will be equal to Fl, Fu is equal to Fd, F1 is equal to F2, Ma is equal to Mb. Friction. The following variables must be considered in solving problems that involves friction. Micro is equal to the coefficient of friction, P for the angle of friction, F is for the frictional force, N for the normal force, R for the reaction, and P for the applied force. The typical friction on a block problem was illustrated here. To solve for this, the formula for the force is equal to micro multiplied by m, and micro is equal to tangent theta. For solving for the belt friction, the following variables must be considered. Micro for the coefficient of friction, T1 for the tension of the tight side, T2 for the tension of the slack side, and beta for the angle of contact. Illustrated here is a typical sample problem of a belt friction. The formula should be T1 over T2 is equal to E raised to micro multiplied by beta. Another is ln T1 over T2 is equal to micro multiplied by beta.